My name's Craig Gallen, and I've been involved in the OpenNMS project probably for the last 10 years, one way or another. I basically support accounts for OpenNMS in the United Kingdom, and I'm a committer to the OpenNMS project. And today I'm going to be talking about a project I've been working on really over the last 6 to 8 months called the OpenNMS Module Plugins Manager. And the idea of this project is to create a mechanism to easily install new features into a running OpenNMS system, much in the same way as you can install new features into perhaps an Atlassian product, if you've seen that, or WordPress, if you've seen how you install plugins there. And this can give us a number of different benefits and advantages in terms of how we deploy OpenNMS features, how we develop OpenNMS features, and also can potentially increase the community of contributors to OpenNMS because many more people can develop plugins that will run on a standard OpenNMS rather than having to install directly into the code base of the OpenNMS system. So I'll rush through this, but and I've got a demonstration as well, but if you've got any questions, stop me and ask along the way as well. So let me see if I can actually change this. Okay, so what are the business drivers for what we're trying to do? Basically, what, oh goodness, it's probably got one of these timers on it. What we're trying to do is boost the value of OpenNMS assets, basically by encouraging wider community adoption and developer participation in the OpenNMS project. And in order to do this, we need a much faster release cycle and opportunity to install things. Now, obviously, as we've moved to the new Meridian Horizon mechanism, that does provide means for people to contribute into the core OpenNMS, but it still is a difficult process, and there are a lot of bottlenecks around getting your code installed into a standard OpenNMS. So if we can create a plugin architecture that allows you to take a working, proven OpenNMS installation and install your plugins on top of it, that means that the quality of the core code is assured, and the quality of your code that you're making as a plugin can be variable, and people will install it at their own risk. But they don't damage the core OpenNMS. They don't make that unstable. They simply install a plugin that has really good or not very proven quality around the project. Now, that's the first thing. Basically, get more contributions and make it easier for people to contribute. The second thing is to enable additional revenue opportunities. And that's not just for the OpenNMS group, but it's also for potential contributors to OpenNMS. So for instance, WordPress plugins, some are sold just as are given as an open source, but there's support is sold around them. There are various different mechanisms by which people can write software and realize revenue based on that software. And that obviously is an attraction for people who want to get involved in a platform. Well, how can I make any money out of that? Now, obviously there are sort of questions around, well, this is an open source project, can we license it, that sort of thing. Well, those are questions and real questions, but they're separate questions because there will be people who will wish to create modules which are in some way licensed for usage. Not only that, but because we've now got the powered by agreements in OpenNMS, there'll be various manufacturers who are using OpenNMS as their core platform, but will want to install their proprietary software on top. And again, the plugin capability allows you to do that and separately license that stuff, so you can have a standard platform and then put in your proprietary stuff on top of that as part of a powered by agreement. So enable new revenue opportunities. And then finally, we want to leverage the work that's been going on in software-defined networks and network virtualization, function virtualization, and also the OSGI adoption, which is now happening industry-wide. And I'll talk about OSGI in a minute, but basically most of the new SDN projects that are Java-based are using OSGI as their deployment architecture, which means that if OpenNMS can fit within that overall architecture and manage that architecture, it provides a real plus for OpenNMS, but it also provides a real plus for those other projects as well who don't necessarily have as mature a model for deploying stuff. So let me talk a little bit about OSGI and Carafe. So as some of you may realize, OpenNMS has now adopted the Carafe container as a means for deploying OSGI modules. Has it jumped? There's some sort of timer in this slide that's causing me problems. Carafe basically is essentially similar to a J2EE container where you would have deployed, wars or other bundles into the container. Carafe is much more lightweight than that, and in this case you deploy OSGI bundles. OSGI bundles are basically standard jar files, but with additional information in the jar header, internal to the jar. That means that the container can look at that and decide how it's going to deploy that bundle. And within Carafe, there's an additional concept of a feature. And a feature is essentially an XML description of a list of bundles. So if I say install such and such a feature, then it will go and find all the bundles that it needs, install them all, and that will be the feature up and running. So a feature basically corresponds to a product, potentially. The idea being that you've got a bundle, Carafe container, you want to deploy a product, you say deploy this feature, and it will pull down all the dependencies, deploy the feature, and it will come up and running as an OSGI feature. So how does it do that? Well, Carafe has an internal cache which contains all of the running jars that it actually has installed, all of the running bundles. And it has a separate system folder which looks very like a local Maven repository. So if you simply want to use RPMs to deploy features into your Carafe, then you basically stick them into the system folder just as if you were sticking modules into a Maven repository, and they just show up in a particular directory structure within the system folder and then can be referenced using a Maven command line to actually pull in the data. So there's a simple way of deploying using RPMs. So if we wanted to offer a new feature using an RPM, we would offer the feature as an RPM, you'd yum install whatever the RPM name was, and it would actually overwrite or put extra stuff within the system folder that would now be available to Carafe to actually load in and use. But separately to that, Carafe can also use an external Maven repo. So if you wanted to use a mechanism of downloading stuff directly off the internet and tell Carafe, install this feature, Carafe can actually go to that external Maven repo, give it the URL, the address, and it will download that into Carafe and start it up just as if it had been deployed in the system folder. So there's mechanisms for doing this offline and doing this online. And the other thing to say is that it's also possible when you define a feature, you can see a little feature definition down here, that you can reference other features. So if I have a feature called My Project, version 1.0.0, whatever, that can reference other features below that, which can have a range of values. So that means that I can create a single product, for instance, that has a version number associated with it. But over time, I can increase the versions of the underlying features that that product is drawing in. And the same product will reference those features because the features, it'll basically install the latest version of the feature that it finds. So if you do a yum update and you install a new version of the bundle, whenever this whole system restarts, it will install the latest version of the bundle as defined by the feature version here. Okay, so quite complex or sophisticated ways of actually defining what gets installed in your system using a feature. So how do we think about this? Well, if we look over here, I'm thinking in terms of product being a service or an artifact with associated price and an SLA. And beneath that, that software product, you effectively for the product, you've got a single unit of deployment, single associated price and license, but it references one or more features or services within a range of versions. So I create my license, I create my product, you buy the license, you install the license, that license will run over a range of versions of the underlying features that represent that product. That means that as you update, you don't have to update your license every time. And an OpenNMS plugin using this idea is a feature with an attached product description. It's got no explicit dependencies between plugins. So the idea is that a plugin may use many similar underlying modules, but there's no dependency between plugins when you're deploying them. So I say I want to deploy this particular feature. You can't say this particular plugin depends on another plugin, because at that level, that's not how it works. But below that, if both those plugins used a library that you've pulled in, then whichever one comes up first will pull in the library and it'll work. So there can be sharing of libraries beneath the level of a plugin, but the plugin itself is just a unit of deployment that you deploy, and other units of deployment shouldn't depend on that initial one. If they need something, they'll pull it in on their own right. Okay? So that's the basic concept of what I'm trying to do here. Now, what we're trying to do is effectively provide a framework for diverse development teams to separate features, to create separate features for deployment, which speeds up and separates feature development life cycles. So, for instance, all the work that I've done, I've been developing against OpenNMS 16. I haven't depended on OpenNMS 17 or anything beyond that. I've taken a stable release and written my plugins against that stable release. And that makes it much easier for any developers who are externally developing stuff to say, I will base my module on this particular release of OpenNMS, get the whole thing working, I can deploy it against that release. So if a Meridian has a 3-year life cycle, I can write against a Meridian, and I know my plugin will work for the next 3 years, because that's the way it's set up. Now, the modules themselves are a set of OSGI components I've described. They can be installed from the public repo, or they can be installed as RPMs. And in addition to this, we've got a web UI which actually runs within OpenNMS. It allows you to determine which modules you actually install and run within your OpenNMS instance. And the modules can contain additional code, additional UI or daemon features, or they could contain additional configuration as well. So this could be a mechanism not just for deploying new code, but also for deploying new reports or other things that are fancy and necessary. And ultimately, we could get to the point where we actually defined plugins for different types of equipment. You know, this is our MPLS solution, this is our Juniper solution, this is our whatever. So that the plugins actually just download and run and install all of the necessary configuration, not necessarily having to change any code. And they can be optionally licensed. So again, if a module has got a license associated with it and the license isn't installed, the module won't start within the Carafe container. But if the license is installed, the module will start. That's basically how it works. Now, again, I'm not necessarily advocating that code be written in a licensed way, but you can see lots of situations where this actually could be very beneficial. Even in the Meridian situation, where the code is open source, you could use this mechanism to throw up a flash on the OpenNMS system saying, this is an OpenNMS Meridian instance which has not been registered. So it still runs, but it throws up the flash saying, you know, you need to register this system. That sort of thing could be used for. So how does it work? Well, the key enablers for this, as I said, are the OSGI container. Now, this was only introduced relatively recently. It's only within the last 2 or 3 releases that this has been introduced. And at this point in time, the OSGI container actually runs within the OpenNMS web container. And the reason why they did that was that they wanted to start developing OpenNMS modules using basically most of the work they were doing as an OpenNMS web app. So all the new web app features that you see have been developed within Carafe as Carafe bundles. But the idea is that over time, the existing OpenNMS daemons will be moved into the Carafe container. And that's the, you know, Taurus was talking earlier on about SNEPO or these minions. That's basically the mechanism it's going to work. Carafe will be deployed first, and then the daemons will be deployed within Carafe. And that will basically run you up as much or as little of OpenNMS as you need in that remote minion, depending on how you configure it, what you want to run up. Now, at the moment, as I said, a lot of the OpenNMS daemons have not been made into Carafe modules, but over time we will get to the point where we have Carafe as the container and then everything runs within Carafe. But we're not quite there yet. However, even though we're not fully there, we can still add a lot of value by adding those modules, even with the state of play we're at the moment. And over time, this will move. And if you've written a module against the API, then it'll continue to run as other things are moved in.
You kind of envisage eventually that you will be able to write custom data collectors.
Yes, exactly. So just to repeat the question, we envisage that ultimately data collectors and any other daemon feature that's currently in OpenNMS not installed as OSGI would become an OSGI bundle. So you could deploy that separately as a feature. But it's just a matter of time to get there, really. Is this going to move or is it going to stay? Right. So in terms of the key enablers for this whole life cycle, it was going to move.
Whenever you turn around.
That's right, as soon as I turn around.
Just going back a slide.
Yes?
How far are we where the application migration on the other side? That's
Well, that's probably more a question for Seth, because a lot of this has been done for the Minion work. So that was, as I was saying, was targeted for release 18. So it kind of exists, but it doesn't all work. That's the short answer. But all the web UI stuff, all the new web UI stuff has been migrated. There's a bit of old stuff still not there. But if you were writing something that was particularly a web UI type feature, then that could be done today. And I think a lot of things people will want to do will be of that nature, rather than needing to be at the guts of OpenNMS. Okay. Now, I should say that all of these modules can get access to most of the underlying OpenNMS features. So, for instance, if you needed to create a new API on top of OpenNMS, one of the things I'm looking at doing is creating an OSSJ API on top of OpenNMS. That could run here because it's essentially an XML SOAP type interface. And it would basically use the standard APIs to call back to OpenNMS and then run as a separate module. So there's lots of things you can do at this level because most of the DAOs are actually exposed already to the Carafe container, if that makes sense. Right, where am I? I've been there. Hopefully this won't, I'm going to go down and come back up and then hopefully it won't move. Right, so the Carafe container is already usable for this purpose, and this stuff can be done. The work that I've been working on, I'm going to show you now, is the sort of license feature manager, which is essentially a series of REST interfaces that allow you to actually deploy and control licensed modules within OpenNMS. So it can be done through the UI or it can be done through the REST interface. I'll talk more about this in a minute. Now, the only thing to say is a lot of this is generically useful for OSGI. So I've developed it under the Apache license, and I want to make it available for any user of Carafe, not just for OpenNMS, because it's a generically useful feature for any Carafe container-based product. The next thing you need is an app store for actually delivering the sort of licensed content, and a shopping cart and all that sort of life cycle around, okay, well, fair enough, you can download the modules, but where do you download them from? And if you do have to pay for something, then how do you pay for it? How do you generate a license? So that's work that has to be done, and I can show you that because a lot of that has been done. This stuff here is more work in progress. We don't yet have a generically good way of extending OpenNMS configurations. If we were to get to this idea of having an OSGI bundle that dropped in and gave you all the configurations for Juniper, we don't have a way to do that yet. So that's work that's necessary to be done if we're going to do that. That would be another OSGI feature that we need to provide. And then at the moment, the APIs that are being exposed are the standard OpenNMS APIs, but there's no sort of OSGI API that remains stable. So at the moment, the problem we have is that from release to release, these things can change. What we've got to get to is the point where we actually have a common API shim that stands between the rest of OpenNMS and the modules, and that stays stable release over release. So you can say I'm working against the OSGI API version 1.1, and you'll know that your modules will continue to work even though OpenNMS has moved on because that API is stable. We don't have that. That's the sad truth. But again, it's recognized as an issue that we need to move to. So for somebody who's developing modules, that makes it a bit more difficult to keep the thing aligned with OpenNMS as it moves. But you know, it's not a blocker from stopping people. Okay, how does it work? Well, the first thing is you've got to make it easy for people to generate licenses and to write code that will or will not start depending on those licenses. I think there's a timer in my slides that I didn't realize was there. That sort of moves it on. So the first thing is that there's an archetype, Maven archetype, that you can use to create a project that will contain all the standard bundles that you need to get things going. So if you want to create a plugin for OpenNMS, you run that archetype and it gives you a plugin to start with. And that plugin will include a license generator, will include a license authenticator, will include a number of other things just to get you going with an OpenNMS plugin out of the box. So you generate your archetype. And what you end up then with is a Maven project that can generate two things: a license specification and a license authenticator. Now the specification is the bit of the license that's used to generate new licenses. So that gets deployed into the shopping cart. So if I want to write a new license, then I deploy this license generator into the shopping cart for this particular product. Now what that means is that it's all public key encryption that's being used to do this stuff, right? So the idea is that I basically deploy the key into the shopping cart, and then if you go to the shopping cart and say generate a new license, you generate it using that key, and it is only actually authenticated if the corresponding authenticator recognizes it. So the authenticator, this encodes it and this decodes it, and if it doesn't decode, you're not authenticated. But if it does decode, then you're up and running. So that's how your license is generated, with variables on it to say what machine am I running with, you know, how many instances, all that sort of stuff. That's done at the shopping cart level. It's coded up, and then the license authenticator, which is another little module that runs within your OSGI module, that will authenticate it and say yes, no, I can run this. So what happens is you generate the spec, you generate the authenticator. The authenticator goes with the product that you actually allow to be downloaded. And that's the thing that goes up into the public Maven plugin repo or into your RPMs. So whenever you download your product into OpenNMS, it has its authenticator already built into it. And if the authenticator doesn't authenticate when it starts up, it'll just die and it won't work. Similarly, the specification goes up into a private license repo, which is run against the shopping cart. And the shopping cart I've got at the moment is WordPress Easy Digital Downloads. But in fact, the whole thing, you know, you could use a different shopping cart if you wanted. And there's a REST API that goes to a local OSGI container that contains all of this license generator stuff. So shopping cart basically says, here's the credentials, give me a license, and the license gets returned and it goes back to the user who can then install it in their system. So obviously, what I'm going to do now is jump to a demonstration, because I think a demo is worth 1,000 words. It makes it much easier for you to understand what's going on. But if you think of this as being providing a similar mechanism to what, for instance, Atlassian does with their plugin modules, this is providing a similar mechanism to actually allow you to have a shopping cart that allows you to download and install things. So let me go to the demo. Hopefully, we can see this. So this is a standard OpenNMS 16 into which I've installed the plugin manager. And to install the plugin manager is just a matter of, well, I'll show you in a minute. It was very simple. So where's my mouse going? So this is the plugin manager. When the plugin manager is installed, it adds a new line onto the admin line. And I click on that, and I'm not authenticated. So I've timed out. So this is the OpenNMS side of the plugin manager. And it's designed to work against multiple Carafe instances. So At the moment, it's obviously only got its own local craft instance, but if you had other craft instances that were running minions, then those would all show up here as the minion addresses. And so the first thing you would do if you started up, you'd reload the instance data. It stores a local cache of the instance data because it may not be able to get to it all the time, but you still want to know what you've got installed. So I tell it to reload, and it reloads the instance data. And so I got the date when it's last unloaded, and I've got the system ID of that instance. Every instance has got its own system ID. Now, what I'll say at the moment, OpenNMS group are using UUID gen to generate system IDs currently for Meridian systems. This isn't using that. This is just a standalone thing. So that's another thing we need to look at and say, well, how can we generate a unique system ID that can be used for both? But at the moment, you can generate a random system ID, or you can set your own system ID, whatever you want. But that's what it is. And every Meridian, every Carafe instance should have a unique one. Okay. Then below that, if I can move down.
Just make one comment on that. I've seen licensing things in the past where they actually hard code to some kind of hardware system ID, and that's actually causes massive problems when you move hardware or obsolete hardware. So having the ability to set it is really good.
Right, yeah. And that could well be the problem with the UUID stuff that they've done.
I know that some use to license a lot of their specifically FlexLM stuff was done through hardware ID, and that's a massive problem.
Right, I'll just repeat for the tape so it picks up, but the comment was made that if you tie the system ID to the hardware ID and you change the hardware, that can cause you real problems in the future. This doesn't do that. This basically generates a random one or allows you to set it. There's no tie-in particularly. Anyway, moving down. So then here we've got reload available plugins. Now this is actually going out to the shopping cart and asking it what plugins are available. And you give it the plugin server URL and username and password to get to it. And then also it's got a shopping cart URL as well. So the plugin server is actually the Carafe instance that contains the information about the plugins. The shopping cart is actually the shopping cart you would look at. So if I just open the shopping cart, you can see it's a WordPress type thing with different things you can download from it. I'll come back to that in a sec. Okay. So let me. Where has my mouse gone? I don't know why it didn't. Right, good. Okay, so on the other side then of the page, I'll move this across so you can see it. You've got the installed plugins, and obviously my mother project is one of them. And then you've got the information here about the actual product, the description of it, a URL that would go out to more information about it, the Maven repository URL from where it's downloaded, and then the license type, and it says here that it needs a license to actually run. If that said false, then it wouldn't look for a license, it would just run up. Okay, and if you've got many installed, they'll show up here as different things. You can reinstall or restart, or you can uninstall a plugin. The available plugins is what's been downloaded from the shopping cart. So I've got 2 available plugins here, and then my installed licenses are the license key, and then metadata about the license, that's all contained within the license key that basically says, again, what's the product ID, where's the repository, where does the Maven system go to get it, the duration, the expiry date, start date, maximum number of system IDs in the license, and the system IDs. So I can specify that this license will run against 10, 15, 20 IDs, and I have to give the IDs. So that means that whenever you're creating a new license, you give it the IDs, it generates the license with the IDs embedded in it, and that's how you stop things running up if you're running on a different system. Okay? And then options. So you can have any number of options which the developer determines around the license. Again, these are options for feature enabling or disabling in different features. Okay, so installed licenses and then add license. So add license, you just put the license in there. So let me go back to my available plugins. I know that I've not got this one installed. So I'm going to install that plugin. Magic happens and you should get a nice message, installed product, blah, blah, blah. And now if I go back to my installed plugins, you can see I've now got 2 plugins installed. And if I click on that one, the license is not authenticated. So it's authenticated for the first one, but it's not authenticated for the second plugin. Okay? So that plugin won't have started up. So if I show you what that looks like, let me just... So this is the VM that it's all running in, and you can't really see this, unfortunately, but let me just try and show you anyway. So this is the OpenNMS carafe, actually running in carafe, and you can log into this. So this is a standard feature in OpenNMS, and I'm actually logged into the carafe OpenNMS in OpenNMS now. So, and if I do list, you can see the modules. And you can see, you can't read it, but what it says is 471 active failure, my project license authenticator. So the authenticator has failed. It has not started up. And the reason it's not started up is because there's no license for it. Okay? Whereas these other ones have started up fine because they found the license they needed and they've run up. Okay? So that's where we're at the moment. Let me go back to this. So, what do I need to do? Well, I need to create an install license for that particular feature. So what I shall do is open a new tab. And hopefully, I've got my latest download. So it's this one here. I know that. And this is my description, which is the same description you get in the other view of the bundle that I want to create. Okay? And I want to add that to my cart. Right, that's fine. And I want to check it out. So it's free, so I don't need to put anything else in. Customer name, last name, just something doesn't matter. All right, I pressed return. So what I've actually done is I've confirmed my purchase, and lo and behold, I've got a license, which is a link to the license. Now you could have several licenses you've purchased at that point in time. But I click on that license, and the license metadata is the thing that I now fill in to say what do I want to do. And what I need to do is to put the system ID in. So if I go back to this and I copy the system ID, and that one there, right? I'm going to get rid of that one, and I'm going to add a new one. I've added the system ID to my list of system IDs, and I can't add any more than 5 because that's the maximum I'm allowed, but you could set that differently for each license. And then I want to generate the license. And lo and behold, there's my license. And you can change this. So this is permanently assigned to you as a user of the shopping cart. So you can change which system IDs. You can only have 5, but you can have any ones you want type thing. So that's my license. And now what I want to do is stick that into OpenNMS. I go to my add license field, and I paste it in. And I just click verify license, and all that does is it proves you can read it. It doesn't prove the license is authenticated. It just says that this is what's in the license. So, that's where I am. Interestingly, you can see it's got those system IDs. So because that license has got those system IDs associated with it, it will start up against this particular instance of carafe. And so now I go to my install plugins, and we can see, I need to click on that one. It's not licensed. I need to restart it. So what that's going to do is stop that plugin and then restart it. And hopefully with a fair wind, now that it's got its license, it's gone green, and you can see it started. And if I show you the same thing,
This is my other project.
sorry?
This is my other project.
Yeah.
You don't install the license, so should not work. I guess you just verify the license, but you're not installing.
I have installed it. Yeah. Well, unless I've done something wrong and you've noticed it, but in principle, I've done it. Let me.
Verify it. You don't
Oh, did I not?
install it.
You sure?
I'm sure. I released it yesterday. If you go to my project,
Okay. Right.
you should
Oh, right. Oh,
and
go to the license, right? Okay, so, right, install license. I'm sorry, thank you, Antonio.
see yesterday.
Yeah.
So
Ah, right, okay. I was just going to lie. You know, none of you would have been any the wiser. Right, so that should have installed the license. It should say down here, license added, right, okay. So now, when I go to installed licenses, I should see 2, which I do. Thank you, great, good. It means that he was paying attention yesterday. That's right. So now, I'm going to try and restart this, and hopefully, with a fair wind, it will work. Yes, there we are. Very good. And if we go to the view of the carafe again, where's my mouse? No. This is here. Right. Click on that one. And just do a list. You can see it's created and it's working. So it's actually active. So now it's got its license, it's working. So that basically is it. You know, we've got a shopping cart, we've got a licensing mechanism, we've got a plug-in install mechanism. The other thing to mention, which I didn't talk about, I'll go back to my slide, is that if these remote carafe containers can't be controlled from OpenNMS, they can still be given an address to go to OpenNMS and ask for their licenses. So they can start up, they can ask for their license and start up, even if you can't actually talk to them. If they're in an address space, you can't talk to them, but they can talk to you. They can ask for the information, and they can start up. So that kind of covers that problem. And because you've got one license that covers multiple minions, they can all go in and ask independently for the license, and then they'll only start up if their code is included in that license.
So it'll be the same license for any number of licenses?
That's the idea, yeah. The only difference is that so this is just the life cycle. I won't talk to that. So where are we at? Well, basically, this stuff works. License manager, feature manager, Maven archetypes, and the plugin manager, that stuff all's there. The shopping cart works. Now, this is a bit rough at the edges because I'm not great at PHP and I've just done enough to get it working as a demo. It's probably okay, but I'm sure somebody could come along and do a much better job. And then what we've got to do is, it's working against 16, got to migrate it to 17. 17 and 18 have got the idea of actual minions in a table in the database, so we can actually populate that directly from the database. That's work that needs to be done. And then I've got some features already that I want to package up. I talked about pmatrix last year. I've done an event gateway for OpenNMS. And the provisioning integration server as well could be packaged up as a module that would run within the carafe container. Those are things that could be done straight away to actually give us a little bit of a working ecosystem. But we've got other ideas of what we could do as well. All of the code is available. Again, a little bit ropey, but it's there in my own repository. But my next bit of work will be to migrate and integrate it and do the documentation. And that is that. So any other questions, or have I?
What access does this have? Because obviously you're talking about fitting to the OSGI model.
Yes.
What data does that give you access to in terms of what's going on with OpenNMS? Is it just everything? Is it events? How does that work?
So OpenNMS has exposed most of their internal DAOs to the OSGI container. So you can wire up a module to use a DAO as a service. So for instance, for all the web UI stuff that OpenNMS is doing at the moment, it's actually making calls through to the DAOs as an OSGI container. And what the module does is it runs up, and it says these are essential services I need, and these aren't essential services. If the essential services are there, it'll work. If they aren't there, it'll fail. In fact, the way I make this work is I make the license an essential service, so it won't start if it doesn't have a license. And actually, truthfully, a good programmer could circumvent that. So I'm not claiming that this is the sort of, thing you're going to use for PlayStation. It's basically for a situation where you trust people, but where you want to provide some means just to control what's running where. But it could be circumvented by a programmer if they were smart enough. But it's still it's better than nothing. Any other questions?
So documentation, it's probably
That would be true. There is a little bit. If you go to my GitHub, you'll see there's a little bit there, but it needs finessing, I would say. But in practice, it's actually very simple. It does need documented, but from a programmer's perspective, not needing to know how it works, you just run the archetype, you get presented with a project, and then you can build your project around that project, and it should just work for you. It's
Creating that archetype is very simple.
Yeah, that's right. And the archetype just produces two jars for you: the authenticator jar and the license jar. And you just make sure that the license jar doesn't get published with your project. That gets published to a separate repo, and that's it really.
And the OpenNMS OSGI, that's documented.
No, it doesn't really exist. What you've got is the DAOs in OpenNMS, which are documented, kind of. Yeah, they've been working on that. I think the problem actually is not so much the documentation, it's the fact that they change. And so what that API layer would do is provide a level of indirection so that when things change, it doesn't stop working. At the moment, you can find things will just go away on you, which is unfortunate. And I think what we'll need to do ultimately is create tests that make sure that as things move forwards in OpenNMS, that API stays stable. But again, that's work in progress. Any more? Thank you very much.